Hello all and welcome back. In this video, we are going to cover VPC peering followed by a quick demo. By default, EC2 instances in different VPCs are not able to communicate with each other using their private IP addresses. A VPC peering connection is a networking connection between two VPCs that enables you to route traffic between them using private IPv4 and IPv6 addresses. VPC peering connection can be established between your VPCs or with a VPC in another AWS account in the same or different AWS region. VPC peering allows instances in either VPC to communicate with each other as if they were within the same network, using AWS existing secure infrastructure with no single point of failure or bandwidth bottleneck. Traffic always stays on the global AWS backbone and never traverses the public internet, which reduces threats such as common exploits and DDoS attacks. VPC peering does not have any separate charges. However, there are data transfer charges. Be sure to know some key limitations and rules of VPC peering. VPC peering does not support overlapping CIDR blocks. You must use private links or VPC interface endpoints. VPC peering does not support transitive peering relationships or edge-to-edge routing. Also, VPC peering connections are limited on the number of active and pending peering connections that you can have per VPC. Remember, VPC peering is a one-to-one relationship between two VPCs, and only one VPC peering connection can be established between the same two VPCs at the same time. In this demo, we are going to set up a VPC peering connection to enable connectivity between two VPCs in the same account and region. However, it can be easily extended to VPCs in different account and regions. Let's navigate to our VPC dashboard. We already had a VPC-A created from our previous demos. Let's visit the resource map. Here the VPC-A. It has two subnets in US East 1A region. The public subnet is associated with the custom route table and has a network connection to Internet Gateway, and the private subnet is connected to the main route table without any network connections. Let's start by creating a new VPC. This time we are going to use the VPC and more option. Let's have a non-overlapping CIDR block. We are going to choose 10.1.0.0/16. We don't need an IPv6 CIDR block for this demo. The number of phases is limited to 1. Number of public subnets and private subnet is 1. Let's customize our subnet CIDR block. I'm going to use 10.1.0.0/24 and 10.1.1.0/24. This gives us a total of 256 IP addresses per subnet. We don't need any NAT gateways or VPC endpoints for this demo, and we're going to enable the DNS host names and DNS resolution. Let's turn off the auto generate. We're going to name the VPC two subnets. Let's name them VPC-B public subnet in the US East 1A region and VPC-B private subnet in the same US East 1 region. Let's associate our public subnet with a custom route table which has a connectivity or a network connection to Internet Gateway, and let's associate our private subnet with a main route table which does not have any network connections. Let's go ahead. This looks good. Let's go ahead and create our VPC. Let's wait for the VPC and its components to be created. And yep, our VPC is created. Let's navigate back to our VPC dashboard, and we have our two VPCs, VPC-A and VPC-B, with non-overlapping CIDR blocks. Let's navigate to the EC2 dashboard. We already have a Bastion host and a private server created in VPC A, and we're going to create a Bastion host and a private server in VPC B. Let's go ahead and launch two new instances. Let's name it VPC B Bastion host. We're going to use the same Amazon Linux 64-bit architecture, T2 micro instance type. Let's select the same demo key pair. Let's edit the network settings. We are going to launch the instance in VPC B in the public subnet with the public IP assigned enabled. Let's create a new security group. We have SSH enabled. Let's add a new security rule with ICMP, and let's add source from anywhere for now. We are good with the security group. Rest of the setting looks good. We don't need an IAM role for this demo. Let's go ahead and launch our first instance. As the Bastion host is being created, let's go ahead and launch our private instance as well. I'm going to name the private instance VPC B private server. Amazon Linux 64-bit architecture, T2 micro. Let's select the same demo key pair. Let's edit the network settings. Let's associate it with VPC B. This time we are going to use the private subnet. No public IP. And we're going to select the same existing security group which we just created. Rest of the settings look good. Let's go ahead and launch our private server. Let's wait for the servers to be available and status check passed. Let's go back to the security groups and let's enable ICMP on the VPC A security group. Let's edit the inbound rule. Let's add a rule for ICMP. Let's add source from anywhere for now, only for the demo. Security group has been updated. Let's go back to the EC2 instances. Let's check the status. Still initializing. And yes, the status check has passed. Let's now do a quick ping test. Let's navigate to our VPC A Bastion host. Let's SSH to it. Let's copy our private IP for the private server from VPC A. Let's SSH into the private server from our Bastion host. I'm going to split the terminal. I'm going to log in into the Bastion host from VPC B. Let's copy the public IP of the Bastion host from VPC B. And let's log in into the private server from VPC B. Let's copy the private IP address and let's SSH into it. We are going to do a simple ping test. We are going to ping the private IP of the VPC B private server from the VPC A private server, and the ping does not work. Now we're going to do the same in reverse, trying to ping the private IP of VPC A private server from the VPC B private server. And the ping does not work. So we are not able to ping the private IPs from different VPCs as they are isolated network. Let's now go ahead and create our VPC peering connection. I'm going to name the VPC peering connection as VPC A-B. Let's select the requester VPC as VPC A. It's in my account within the same US East 1 region, so no changes in here. For the acceptor VPC ID, let's go ahead and select VPC B. No tags required. Let's go ahead and create the VPC peering connection. And yes, the VPC peering connection is now pending acceptance. If you are creating a VPC peering connection in a different account, you would need to go ahead, log in into the account and accept the connection. For this one, it's in the same account, so I'm going to go ahead and accept the request. We can go through the attributes. The requester VPC, the acceptor VPC, the CIDR blocks. The requester and the acceptor owner ID remains the same. Let's go ahead and accept the request. And the VPC peering connection has been accepted and in the status is active. Now that the VPC peering connection has been set, we need to modify our route tables for the VPC peering connection entry. Let's edit the route in VPC A main route table. The destination is 10.1.0.0/16. That's the VPC B CIDR block. And the target connection is our VPC peering connection. Let's save the changes. And let's modify the main route table for VPC B as well. Edit the routes. Let's add an entry for 10.0.0.0/16. That's the VPC A CIDR block. Let's add the target as the VPC peering connection now. Let's save the changes. Remember, without the routing table changes, the VPC peering connection would not work, would not be able to route the traffic between the two VPCs. Now that the routing table changes has been done, let's try to ping the private IP addresses again. And yes, we are now able to reach the private IP of the private server in VPC B from VPC A. Let's try the reverse. And it works as well. So we have now successfully created a VPC peering connection between VPC A and B. I hope that you enjoyed this demo. Thank you all.
Alright, that was it. Thank you for watching. You can check out my website and connect me on LinkedIn and Twitter. If you enjoyed this video, please give it a thumbs up. For any feedback, please leave a comment down below. To see more videos like this in the future, hit the subscribe button. Thank you.